And yeah, and your interest is in kind of research focus on educational and labour market outcomes. And also you are funded by the ESRC, the Understanding Inequality Projects.
Yeah, that's what it says on my ResearchGate account, but it's not up to date.
Oh, okay, well,
but on another ESRC project in a similar vein.
Okay, great. Well, take it away. Thank you.
Okay,
for coming.
Sure. Today, so I'm going to go talk about basically studying peer effects in the Northern Ireland Longitudinal Study. But I was invited here by Gaz because he thought it might be of interest for me to talk about the work that I do with regards to work causal inference, primarily using a series of quirky natural experiments and or quasi experiments. So yeah, I guess, what do? Well, you already got an introduction to what I do from over there. So it really depends on who you are. So I've moved around a lot of departments to a lot of fields. So I started off as being that guy in Cardiff University around the social science department, where they usually have, if you had a stats question, they usually recommend you go to me. Like, should I use, what type of T test should I use? That's what the questions I got a lot from that department. But like last week, I gave a talk and at the economics department, and I was introduced to some sort of spatial econometrician. So let's go with that. I'm a spatial econometrician. And basically lots of my work sort of involve, well, I have an interest in causality, but I have a really big interest in doing the type of research that you would call shoe level research. So lots of studies that use design-based studies to estimate causal parameters. I mean, there's a quote by Ernest Rutherford taken entirely out of context there, which gives you the sort of like general thrust of that sort of work. So work where confounding and all sorts of endogeneity issues is naturally taken care of because of the design that took place and what happened. So I think I should probably, before I talk about NILS, I'll give you a bit of an example about some of my other stuff that I've done. Simply, it's not all, it's mostly not in health. It's mostly in economics, but it may or may not give you some sort of idea, because there's really also, right, that the other reason why I don't have a very good job title is because there's no consistency to any of this stuff with regards to what theme or work it's under. So give an example, paper one. So basically there was a social housing regeneration scheme in Glasgow. It cost £4 billion, and they were going to redo up social housing in all of Glasgow. And we basically in the paper evaluated that. So the treatment is the social housing regeneration. And the outcome we wanted to find out was, did it increase employment for the residents of Glasgow? Because £4 billion was going into the economy and people voted for this stuff. So the way that we evaluated that is we exploited Glasgow's arbitrary administrative borders. You see, the intervention took entirely place only for buildings that were within Glasgow city's borders, and Glasgow's local authorities' borders are arbitrary where they are drawn. The actual metropolitan area of the city is bigger than that. So you can find lots of places who fall just outside the local borders who would have been eligible for the treatment, but were not. For instance, their Glasgow city borders actually shrunk in 1996. So there's a quadrant in the southeast there of the city that I've drawn out. And basically that area left the city in 1996. Before, for 30 years, it was completely governed by Glasgow. It left it to join a newly formed local authority called South Lanarkshire. So this took place like 5 years before the intervention began, but because social housing tenants don't really tend to move a lot, or we can find out how many of them moved, it's a pretty good control group for the area of people in Scotland. Similarly, Glasgow, the yellow spots are index of multiple deprivation, but you can see in the neighbourhoods of index multiple deprivation spill out over Glasgow's borders. That's because the urban area is artificial. The administrative borders are, again, a bit arbitrary. So the urban area is bigger. So you have lots of overspill in very poor, deprived areas that spill out beyond the borders. Again, they never received the treatment, but they would have been eligible for it if things had slightly changed. Another one is about new refugees and homelessness. This one is a bit tough to work out, but basically it involves some knowledge about what goes on in the asylum system. So people come to the UK as asylum seekers and they're not allowed to work as asylum seekers whilst their asylum application is being processed. But when they're asylum seekers, they can also be housed in state housing for asylum seekers, because you come here from, let's say, like, I know, Syria, you're destitute. You came here to escape a war. You're not exactly going to have like any monetary funds to house yourself, for instance. Well, it just so happens that when asylum seekers get permission to remain in the UK, they become refugees, they're given 28 days to evict their social housing and then just leave, okay? So these people have not been able to work as asylum seekers. They don't have a national insurance number. You know they're destitute because they wouldn't have gone for state housing anyway. PS, it's the rules of the UK that if you're an asylum seeker that is not destitute and can find your own housing, you go find it. So they're given 28 days to leave, evicted. And people would say that that's kind of cruel. It's kind of stingy at best. But there's also a lot of concerns that people just go homeless. They just go under the radar in the system, essentially. So that's the policy that still remains in the UK to this day for England and Wales. But funnily enough, because of devolved governments in the UK, Scotland can't change its migration laws, so it can't change what we do to immigrants, but it can change housing policy. And in 2003, Scotland changed its homelessness policy in such a way that de facto refugees got priority access to social housing by dint of the situation that they were in. So that's the treatment group. Treatment group in Scotland got a different, basically effectively faced no eviction, potentially. So that's a control and treatment. And basically the design is refugees are actually dispersed, asylum seekers are actually dispersed at random throughout the UK. So this has happened since 1999 because previously they all just used to live in London and London got sick and tired of that. So if you want state housing, they're going to disperse it at random across UK. So you have your treatment and control, England and Wales and Scotland, and you have your pseudo randomization. And finally, to measure the outcome of homelessness, because we are measuring homelessness, that very hard to measure outcome. Coincidentally, around that time, there was a postal survey. And I'm going to make the assumption here that you being homeless is going to make you less likely to answer postal surveys. That paper is quite complicated, but you can go read about, I'll show you where to read all about it. But yeah, we basically inferred from homeless response rates to that survey, the effects that that Scottish policy had on homelessness. And then here's another one. This is my latest one funded by the BA Small Grants. Thank you, BA. Basically, the treatment is online crime maps. So you might not know this, but you may already know this, but there's a government website called police.uk. And since 2011, you can just type in your postcode on there and find out what crimes have occurred in the streets around you. So this is street level crime data. Basically, the treatment I want to know is basically if around the corner it says on that map that there's 10 crimes, how does that affect property prices? So I'm not talking about the effect of crime. I want to know the signaling effect of crime through that crime map. And the reason why that sort of matters is when it first launched, lots of estate agents said this will just drive down house prices in my area, which will presumably drive down profits. So the outcome is house prices. The design here, though, is quite interesting because what the public sees is not where the real crimes are occurring. To protect victims, crimes on that crime map undergo a geomasking algorithm that can be reverse engineered. I won't explain to you how that can be done. But essentially, what the public knows about crime and where crimes actually occur is what I call the geomasking error. And that geomasking error is basically quasi-random because we know how the algorithm works. So essentially, we can use that geomasking error to work out the effects of that crime map on house prices. To give you an example about how this error occurs, you can go look at that cul-de-sac that has 151 crimes in it. There is not 151 crimes in that cul-de-sac. It's because it's next to an ASDA and the geomasking algorithm has jittered it. So situations where that has happened, but more subtle because the public doesn't know, for instance, like that 23 crimes near a church. Did that really happen there? Or did it happen like 200 meters away? Public doesn't know that, but we can work out the difference between, yeah. So basically that's that part. So yeah, as before, none of those studies have very little in common with each other, but that basically sums up what I do. I'm here to actually talk about peer effects, which will be completely unrelated to what I just talked about there. Basically, which is why peer effects? I mean, does your peers, who your friends, family, neighbours, whatever your peer groups are, do they affect your own behaviour in a sort of imitative fashion? And the peer group I'm interested in here is neighbours, like literally, as I'll explain to you later, your next door neighbours, the people that live next door to you or the people that live with you. And the peer effects behaviours that I want to look at is basically like fertility. In this case, if a woman has a baby, does this induce a high probability of her next door neighbour having more children? And secondly, labour market outcomes. If a woman joins the labour market, does this cause her next door neighbours to have a high probability of joining the labour market too? That type of peer effects. It's probably simpler to talk about what I don't mean. So what I don't mean by peer effects is I don't want to talk about homophily. So I don't want to talk about the reasons about why similar people with similar number of children or labour market outcomes live next to each other. I don't want to talk about common causes. I have a really bad example of what common causes to give for fertility, but there are common causes for labour market participation. For example, there could be a local job training scheme that targets people in specific neighbourhoods. And other things like Sure Start, aerial level intervention. Don't want to talk about that though. The causal arrows I want to know about is the green arrow going from household A to household B, and the orange arrow going from household B to household A. So that type of peer effects, which is kind of a bit difficult as well using observational data, because without an experiment, in observational data, because you have this sort of reflection problem where A affects B, B affects A, so on and so forth, the statistical correlation, even without homophily and common causes, is biased. But it's biased in a certain direction, so it's not so bad. But yeah, the big ones are the omitted variables issue. So why study peer effects? Lots of reasons. I'm just going to go give them, but really, yeah, this is the last reason that I'm interested in. So basically, it is a potential cause of long-standing health inequality. Certain areas have very poor health. Certain peer groups also have very poor health, which is, and if peer effects has been offered as an explanation. There's also helps to tell us a bit more about the social multiplier effects of policies. So for instance, if you have a smoke intervention, it affects the intervention group. Is there some sort of spillover effect where they affect their peers? Like, Bob stopped smoking, maybe I should stop smoking. If true, fantastic, because you could generate value for money in your policy. It's affected people that you weren't intending to affect. But again, it could have unintended bad consequences. So for example, Bob's quit smoking for like a month, but because all his peers do it, he goes right back to smoking. So, and also I'm some sort of geographer, urban guy. So it's actually mixing peers and neighbours in a neighbourhood is actually the idea behind a lot of policies that are touted, such as tenure mixing, where you mix people with social rent and private owners together to create some sort of positive role model effects and things like that. But it's also, it's like the classics problem in sociology since the beginning of that discipline, which is like, we're not all a bunch of individuals summed up. We are individuals interacting with each other, and we would like to know things about that. But generally, it's also quite hard, and that makes it interesting from my point of view. So that's why I like to do it. And why fertility? You know what, I can probably skip this by saying NILS is a health study. So it has to, your thing you have to study has to be related to health. So I needed something related to health. But the reason why you would probably want to study fertility in Northern Ireland is that there's a demography reason for it. So Northern Ireland whoever's in charge of Northern Ireland can call a referendum on whether or not Northern Ireland leaves the UK under the Good Friday Agreement. And if a simple majority votes for that, Northern Ireland is out. Under the circumstances under which you would call that referendum is probably when you have good evidence that the majority wants out. Specifically, if the Catholic population of Northern Ireland starts to outnumber the Protestant population. So there's a demographic side to fertility when we're talking about Northern Ireland. Although that might be a bit moot because Brexit, happened, and that could have just completely sped up the process. But really, what I'm particularly interested in is actually labour market participation. I always am, and fertility kind of has a knock-on effect on your labour market participation. I can tell you that as the father of a 4-year-old, it really does change your labour market participation in a big way. Anyway, that's enough about that. So it's hard, it's great. How can we measure peer effects? Think of the ideal experiment, and I'll show you what I'm going to do here. So basically, in the ideal experiment, what we would want is to intervene on household A using an experiment for fertility. Let's just say like folic acid in the tap water of random households in Northern Ireland, or what have you. Don't worry too much about that. And then basically, we need the treatment and control. We check that the intervention has affected the outcome in the treatment and the control. And then we find out which households has a neighbour in the treatment control in household A, so household B. So we're looking at people who are neighbours of the treatment control cases, and we find out their outcomes. So for the neighbours of the treatment group, are their outcomes different from the neighbours of the control group? And that bada bing, bada boom. Easy experiment. All you need is data on households affected by the experiment and a sample B of their peers. Really easy, apart from it's not, and the ESRC will just decline my experiment to spike people's drinking water. So that's a no-go, but we do have everything we need. We don't need a real experiment. We can rely on natural experiments that affect childbirth, which I'll get onto. So if you have that, that's sorted. You then need data on people affected by that natural experiment, or in this case, households, and their neighbours. And we'll plan to get that data from the Northern Ireland Longitudinal Study. So what I'm going to show you is basically all the pieces that bring this together. So first of all, natural experiments that affect childbirth, tons of them. Right, so the one that is probably going to have the most power, that is my main estimator, is basically, so did you know that basically for parents that have at least 2 children, the sex of your first 2 children affect your probability of having a third? So across many cultures in the world, if you have 2 boys or 2 girls, you're more likely to have a third child than if you just had a boy and a girl, no matter what order. And this is an effect that we found like in Mexico, USA, originally found in the UK, believe it or not, and Greece, it exists. We know for sure that it exists. We also know for sure that in this country, children's sex is random. You're not allowed to select on children's sex in this country. It's illegal. So if the sex of the 2 eldest children is the instrument, then it's an instrument basically for having a third child. So that's natural experiment number 1. Bonus round though is of course twins. Twins are 1% of all births, and twins is basically a random 1% of all births. You guys might know this better than me, but IVF does confound it because IVF does induce multiple births, but the proportion of all twins that are IVF births, conditional on twins being IVF, is still not that high. So the bias is not that huge. And month of birth, which is not an instrument for fertility, but it's an instrument for mother's labour market participation. So basically, you probably know this, but school year starts at a certain date. So children that fall below, that basically are born before and after that cutoff are maybe only a few days apart, but some of them start school an entire year earlier. Well, for children that start at school an entire year earlier, their mothers are more likely to be on the labour market during that year because, as I said before, you have a child, you can't get them into school, that really affects your labour market participation. So that's a natural experiment for labour market participation, which can be used for looking at peer effects. So those are the natural experiments. I'm sure there's more. I'll speak to you about it in the end because you don't have to shake the natural experiment tree very hard to get these. NILS, why NILS is important is, NILS is based on the Northern Ireland census, basically. It's 20% random sample of the Northern Ireland census. They picked out the sample by looking at, they've got a list, master list, secret list of dates of births, like, I don't know, 10th of July, which is my date of birth. And they picked out every single member of the census that had that date of birth. So that's their random way of picking it out. But it's 28% of Northern Ireland census, and it's linked to other records in Northern Ireland, like health records, administrative data. Someone's even linked prescription data to NILS before. So it's got quite a lot of health variables, and it was set up as a sort of health study. So it's sort of data on that is particularly good. The unusual, well, it's not unusual, but the interesting feature about NILS is it's got a 28% sample of the census. And the reason why is there are equivalent studies in England and Wales and Scotland, and that use 1% and 5% respectively. But because Northern Ireland has such a low population, NILS has to sample way more to get the same statistical power as the rest of the surveys in England and Wales and Scotland. So that's their explanation for the 28% sample, but unintentionally, this creates a fantastic sample of households. Because you see, once someone in your household is a NILS member, for that year, census year, every single member of their household is also in the study. So whilst only 28% people randomly drawn, you get more people than that in the actual study. And also you get 50% of all households in Northern Ireland, which is going to make what I'm going to do really useful, because say you have you as a household in Northern Ireland, the chances of you getting your neighbour on that side and that side is around 50% each way. And also the sampling strategy is known. So there's no selection bias. You know how it's done. So you can account for any sort of selection issues later on, as I'll talk to you about weighting. But the other interesting fact is, unlike, I think, Scotland and England, someone's bothered to link all of the NILS address census data when someone filled in a census. This is their address. They linked it to a database of all addressable properties in Northern Ireland called Pointer, which I'll show you in a bit. But it's really quite cool. And as I said, it's linked to a lot of health data. So that addressable properties data called Pointer is absolutely essential, because basically what Pointer is, it's a database that's kept by local authorities and Royal Mail, and on behalf of Land and Property Services, it's updated. It's a rolling data set. It's constantly updated and its quality is really good. Okay. And what it has in it is, for every single building that has an address in Northern Ireland, it knows its coordinates, like bang on. This is where the coordinates of that building. And for each place within a building, it also has a unique property reference number. So if, for example, you're living in a flat, like same building, but multiple flats, every single one of those flats in there would have their unique property reference number. And that unique property reference number is also sequential. So flat 1 and 2 and 3 have a sequential random property. Well, they're not random anymore because they're sequential, but they're sequential. So you know who's basically in a high-rise flat, who's flat 1, 2, and 3, and who are their neighbours. Yeah, so it's not. And the other thing about it is, knowing where people live is personal data. That's disclosive. But the Pointer data, as in literally this building data, buildings aren't covered by GDPR. So the Pointer data is not free, but it's not restricted either. You can manipulate the Pointer data as and when you want to find out, as I'll show you, the neighbours. So how close is close that I'm talking about? So this is using a sample of the Pointer data for Derry. So this whole map segment here has roughly 140 addresses on there, and that corresponds to a census output area, which is pretty disclosive by itself. If you try to get survey data with like output area, it's just not gonna happen. Most people will tell you that's too close. We're not looking at that. The blue circle, that's postcodes. That's 38 properties. There's no way in hell you're going to get census data on postcodes, because that's just super disclosive. But we're actually looking at that orange dot here. So you see that circle of those. So if the household in the middle is that orange dot, and the circles shows it's like 4 nearest neighbours, that's who I want to know, those close neighbours. So the furthest away, the fourth furthest away neighbour is like 12 meters away. The closest neighbour is literally 6 meters away. People that, quite frankly, if you're not exposed to your neighbourhood, then you're exposed to no one else in your neighbourhood. They're so close. And that's the level of resolution that we want to look at. So the big question about why I started this study, and the big challenge is, this is so bloody disclosive. Like, there is no way they're going to let you look at that. But that's okay, because as I said to you, the Pointer data is not restricted. So this location data is disclosive, but that's not needed for all the estimation that I'm going to use later on. Instead, you can take the Pointer data, which is not restricted, create an edge list, which is basically a table where for a particular household or particular property or ref address, sorry, who are its 5 closest neighbours in Pointer? Are they in, well, we won't look at are they in NILS, and how far away from you? So this is a master lookup table that you can create just using Pointer. And then NILS can join up using unique property reference number, the NILS members, to that table. And once that data is joined up, it's not disclosive, because from that table, you can't bloody work out where anyone lives, because it's got no geographical identifiers. Even better, if you pursue a natural experiment route, you're just ordering like 5 variables at a time. There's not enough disclosure in the variables that you're ordering to identify anyone. So you want to The only thing is to be careful not to order any other geographical identifiers with that edge list. So if you want to ask what county they're in, that will be a bit shaky. You want to also set the distance, because if someone only has one neighbor and they're like 8 miles away, it's dead obvious who that is. So there's a bit of things that you have to do, but it's easy peasy. I'm sorry, I was just to point out, this was a big challenge, explaining to the census Northern Ireland Longitudinal Study and like the census team, like, I'm not a madman. I don't want to break GDPR. This is what I'm proposing to do, and it's very sensible and not insane. Okay, we got past that stage. It was really easy, actually. But yeah, if you go straight out and ask them for like output area data, they'll just chuck you out. Okay. So basically, how do we estimate peer effects? Well, now that we have all that stuff, it's really easy. Step one, you just do what I go get your natural experiment. So let's say mixed sex instrument. Find out it actually had an impact on childbirths, which household A. It probably does. I'll show you why in a second. And then find out for the treatment control group who have basically find out from the neighbours of those households their outcomes. And there's no step 3. That's the 2 steps. Your extra step is probably to combine step 2 and 1 into the IV estimator. But that's it. You also need to adjust for the fact that because NILS is around, larger households have a higher chance of being included in NILS because there are more people to draw randomly from. But that's really easy to correct for. You just use inverse probability weighting. There's a document that I'll show you. Well, there's a link to the draft of the study protocol that will show you how easy it is. It's easy peasy. Yeah, I don't know why I include this table, but just to hammer it in, this is the estimator. It's 2 tables. So table 1, how much does having mixed sex first 2 children versus same sex affect your probability of having a third child? This is based on the pioneering UK study, really, that discovered it at the same time as a bunch of Americans. But Maria Yakova estimated it's like 10% higher chance of having a third child, which I think is too large, quite frankly, because it's way over the international, what they found internationally. But hey, I expect it to be 4%, quite frankly. And I'm going to go with that for power. But yeah, and then step 2, just go find out for people whose neighbours have like same mixed sex. The sample B, people who have sample A as their neighbours, work out what the average number of children they have. And you're done. So that's the main estimation, but an estimation is not as interesting as the sort of robustness test you have to do for it, because you want these robustness tests to pass. So you want to check that child sex is random, it'll be random. You want to check that birth order, like having a boy and a girl versus a girl and a boy first, doesn't create some sort of subgroup effect. It doesn't. The multiple studies have shown it doesn't. You want to check that the proportion of neighbours with like the same sex instrument in your neighbourhood is like random and not correlated with other things like deprivation. It's going to be all right. And you want to check that the timing of births. So people could have extra children and then they can move to areas where other people have extra children. If we're just using, the raw census cross-sectional data, you can account for timing of birth just by making the dependent output for your outcome for your neighbours, the amount of births, the amount of children they have that are younger than the first 2 children of their neighbours, or you can just use the live births data that NILS is connected to. For that, you'll lose some power, but you can check for that. And yeah, there's lots of like sensitivity analysis. So what neighbours matter? Like your first 5 closest neighbours or your closest neighbour? Who knows? Just go test it out. No one knows. Certainly also PFX might be flow stronger if you and your peers are similar, like if you're from the same religion. It's Northern Ireland, so that kind of makes sense. We'll test for that as well. And you can subgroup by education and marital status. So the instruments of the same sex instrument, that's been found to really only have an effect for people with lower secondary education, rather than it is for women with like university degrees. And even better is, data has not been extracted for this study. So the whole reason why I sort of want your feedback on this is I'm writing a pre-registration, which will have all of the study, the estimators, the research questions, the whole shebang in it. So later no one can turn around and go like Meng Le's like data mine this, no. Yeah, so for sample and power size, well, you know, if the worst case scenario, which is based around just public available census data, sample A, people who have at least 2 children in in either 2001 and 2011, is only going to be 23,000 people, whilst their sample neighbours is only going to be 2,300, which is adequate, and also based on a ridiculous assumption that neighbours who are similar don't live next to each other, like neighbours are distributed around, which is just, yeah, ridiculous. But I don't know the actual statistics from public data about that. But in the worst case scenario, this will probably work out just fine. So progress, basically, this was funded in 2019. I was supposed to extract the data in 2020, but then COVID hit and closed down the entirety of Northern Ireland's longitudinal study. So there was can't do this study. So I had a lot of time to, you know, twiddle my thumbs and write up this study protocol. The really interesting thing about this is originally, I expected this to be a complete ethical faff, quite frankly, because originally I actually didn't ask for people's 4 closest neighbours or anything like that. Originally, I just wanted a dummy variable for their postcode, just like, you know, some sort of quasi-random number, and then we can use fixed effects or something like that. But it was actually the research advisory board from NILS that went like, you know what, it's probably less explosive if you just ask for like their 5 nearest neighbours, because with entire postcode sets, you're getting a lot more information with this. Yeah, so yeah, we got better research, even though we didn't ask for it, which is fantastic. And at present, I'm trying to make the edge list, but it's going to be done. It's just NILS has to ask the census team at Northern Ireland for permission to extract that data, which means another round of like, this is not insane and will not disclose who people are.
When you're continuing.
Is it 2 o'clock?
Yeah, yeah, 2.
Okay, we've got teaching, it starts at 2, and normally it takes about half an hour to set up, but we'll call it now. Okay.
Sorry, yeah.
All right, thanks.
Yeah, so I'm going to go write this up as a pre-registration, put it on Open Science Framework. Although someone's told me that I've just recently learned of registered reports, so I should probably maybe try out for registered report in +1 instead, where you just submit your research design. They'll accept it in principle as long as your research design is followed, and then you just get the results and they'll publish it, which seems like a pretty cool way to go. Do me a favor. So there's the rough version of that is based on my GitHub pages. Go read that if you want to do me a favor and find out whether or not there's any issues in it. It's got tons more stuff about weighting and stuff like that. If you want to know how exactly I'm going to go recode and manipulate the variables, you can go read that. And also, yeah, so last point is, why should you care? Basically, as I presented this internally, studying peer effects isn't easy. I just completely glossed over the fact that it isn't easy. But it's a really good recipe for future studies, because so long as that pointer edge list is made, you can just take this design, the NILS data, insert in your own natural experiments, and bam, you have a brand new paper on peer effects of whatever the hell your natural experiment actually affects. And it'll be easy peasy, and you don't have to go through the faff of convincing the research advisory board that you're not doing some sort of crazy person research. So how do you find natural experiments? Honestly, like I said at the beginning, I didn't shake the causal inference tree very hard to get these natural experiments. You basically just, if you want to look for your own original one, by all means do, it's really fun. But you can also just literally find out existing natural experiments that have not been exposed to use to measure peer effects, and look at that. So the same sex instrument was discovered at the same time by Maria Yarkova and Angrist and Evans, and Angrist, in a really good timing, is one of the winners of the 2021 Nobel Prize for exactly this type of design-based, very strong internal validity research. And this whole design was based on an original French paper in 2009, where some read that paper, it's extremely good. Where some very clever people found out that the French labor force survey, the way that they interviewed that French labor force survey to save money was they basically selected an area and interviewed all households in that area, because they physically had to go up and talk to people. But that means that you have basically a complete area and all their neighbors. So they used the cluster sampling that in their study to basically look at the same things I did, fertility and labor market outcomes. My only addition to this is the fact that I realized that Northern Ireland, because of its like weird scenario that led to its 28% sample, fantastic sample of households as well. So yeah, first of all, thank NILS for this. I've had to go get it approved as the final output, despite the fact that I have no data to show you. But so yeah, that's you can totally read about my other studies here. It's in my ResearchGate profile, which is not updated. But you can read about the other papers as well. So the Glasgow paper, that's been published this year. The refugee paper is still a preprint and under submission somewhere. And that's an old copy of it anyway. The crime maps paper is, I still have to do a pre-registration, but that bit's funded by the BA Small Grant. And there's an interesting one that I haven't talked to you about, but about Norwegian integration policy, where we leverage basically something that happened in that policy where people who are over 25 got bigger incentives to participate than people who are under 25. And obviously we use a classic regression discontinuity like kink design to go work out the effects of that. That's awaiting pre-registration. I haven't seen that data yet, so I don't actually know whether the instrument works or not. So it's a big gamble, but that's what pre-registrations are for. So that's that.
Any questions? I'll have a look at the chat as well, as they've been popping up.
Yeah.
Do you want to start off, Neil?
Yeah. So one thing just on the power calculation, so it's the comments on that. The models that you're using are actually exactly the same as that paper over there. So power calculation. So
Yeah, I totally agree. I didn't. So step one, step two. So you know, step one, you estimate the effect of the instrument on the treatment, and then step two, I've actually shown you is just the effect of the instrument on the outcome. I've mainly centered a power analysis around that rather than step three, which is the evolved estimator. But yeah, I can do that. But I mean, at this point in time, the big unknowns basically how many neighbours do these people have that are within, you know, because it's no good if, so that's kind of unknown, and that's kind of that sample size I just don't know, and we won't know until we get to the study.
So with natural experiments, the big issue is always power. Precision to basically have reasonably precise enough results. So kind of the strength of the instrument is very similar to a lot of the pharmacoepi work that we've been doing, and you kind of ideally you're looking for tens of thousands of observations to kind of get the level of precision you need, just because you're using such a small proportion of variation in exposure. Yeah, it'd be interesting to see how it all shakes out, I guess.
Yeah, well, I mean, I totally know. I totally agree with you. Yeah. So that is generally, by the way, with all the papers that I've done, sometimes you actually do get the exact power that you need, or the effect size is quite large that you can detect it even in low power, like for example, that was homelessness fee. But sometimes not. But yeah, it's sort of the gamble you take natural experiments. You're applying the internal validity for power.
Okay, great. Sorry, the people on the Zoom, apparently they couldn't hear us. But has anyone got any questions on the Zoom call? Okay, I guess I'm hoping everybody can hear me now, but we've got one Q&A. Yeah, the live questions be repeated. Oh, that's annoying. Yeah.
Well, there's only been one live question. So
yeah, that's true. There's only got one live
question. The recap is basically there's a method for calculating power sizes for IV, and also this is a natural experiment, and natural experiments are a chuck of the dice, really. So randomness gives and randomness takes, and one of the things that it takes away from you is most of your sample size. Natural experiments tend to have poor power. So I think, sorry, Neil said that tens of thousands is usually what we need, unless of course, you know, your effect size is ludicrously large, then detect away. Yeah, so in this case, it'd be interesting to see what actually happens out of the actual sort of experiment. So in the original French case, where they had a very comparable sample size, they had enough power to detect an effect size for labour market participation, which I haven't talked about so much.
Yeah.
But that's why it all sort of work. And obviously, you know, the other instruments like twin births, that's going to have not as good power as that. So that's why I'm not bragging to you about twin births here. But yeah, we'll go basically.
Yeah, the twin births and the same-sex initial births is particularly speaks to me quite well. My neighbour has twin boys, and they decided to have a third kid. I had two boys shortly after they had their twins. We decided to have a third kid, and we both got an additional 2 boys. So between 2 houses, we got 6 boys. 2 and 7. So.
I mean, yeah. Also, the twin births identify as a different treatment effect, because it's a treatment effect of fertility induced by twin births rather than the treatment of, yeah. So your neighbour could go like, Neil's only got like 3 kids because he only wanted 2, and that might not, you know, affect their behaviour. But yeah, potentially also because there's multiple instruments, potentially some sort of multiple instruments should be combined. But
anyone else have any questions? Okay.
Sorry, Jimmy, I think Kate Tilling had one in the chat.
It's not appearing on my panel list. There you go. Okay. Yeah. Oh, there you go. So how do you go about finding your natural experiments? Any advantages to policy via natural, e.g. twins examples?
all right. Well, the first one is a question I really want to know, really, because it's something that me and Gaz talked about, which is I really like to ask people that find these natural experiments what they were doing. Like, you know, if you literally always find natural experiments, just get in the bath and listen to some Little Mix and run a bath. How do I find them? Shoe level research, really. I think it always starts off with the fact that my biggest advice is to look for your design first, make sure it's chock-a-block valid, and then look for what can you answer using the design. So find interesting things about the world, and then find out what you can use to leverage, how you can use that to leverage it to answer questions that are really hard to answer. Like, for instance, you know, that police crime map thing with the whole 151. Yeah, so I think we were talking about this during lunchtime.
Yeah,
it's not like it's not like the most financially viable way to sell your stuff to the SRC. But it's a hoot. It's a lot of fun. And yeah, and then once in a while, like, well, it does clearly has worked, because the 3 people that won that 2021 Nobel Prize,
right? Yeah.
That's what they do, and they're really good economists. Any advantage to using policy versus natural experiments? So this is one of the reasons why I wanted to come to a health place. This is the reason why I'm showing you this instead of the crime maps thing, because health has got a bounty. I think someone said it, I can't remember if it's Pearson, but health has got a bounty of these natural experiments that have occurred. So you guys do what, Mendelian randomization and that, and yeah, twin births. There's a lot of these in health, and you guys can probably insert in your own natural experiments, put it into NILS, and then run away with your paper on peer effects. Feel free, but I mainly do stuff induced by policy. And the good thing about policy, there's no advantages apart from policy. Often it's like there's often one person that decides how policy is allocated, and if you can find out how that one person did their job, you can basically know whether or not you can adjust for how you can adjust basically do your natural experiment. But you've got to be equipped with the fact that, hey, you've got to do the shoe level research, which is like, often it's actually just tracking down documents. So the National Audit Office is really good for this. But the other thing is just like finding out who this person was, what information that they have access to, because anything they didn't have access to is not something that is a confounder. And yeah, just shoe level research. And hopefully, you know, after you have that, then assuming that it can be possible, if you're just using the information that you have at hand, you should be able to derive non-parametric estimators. So most of the time I just use exact matching, no statistical assumption, functional forms contained in there. And then, yeah, it's all good. It's fun.
Yeah. Great. So, I think you're right. There's lots of examples in health policy. So changes in relation to smoking tax, alcohol tax, differences between Scotland and England and Wales, something we're working on at the moment. And also not just policy, but there's a very dangerous person that if he was leading, in my opinion, a drug company would be in big trouble, but who promotes a particular way of trying to identify at risk and prevent stillbirth. And is terrified, is big, and I'm from a sort of obstetrics background a long time ago. So he terrified everybody in the Royal College of Obstetricians and managed to get most obstetric units in the UK doing this, despite with concerns. But Scotland hasn't. And so we've just done the difference. They have the same NHS, and the change since the Perinatal Institute GROW protocol started in England and Wales, the stillbirth rate is, the dip is slightly greater in Scotland than it is in England and Wales. But clearly, if that's all to do with GROW, we wouldn't expect Scotland to be doing better when it hasn't taken it up. So there's definitely lots of examples like that, and often geographically based.
Yeah, so this is one of the things. Yeah, it's quite often because policy might just like to disperse it in whole area interventions. They're all, if you know how it's randomized, they're cluster randomization. So you can really, really go to town if you know, and you have to basically work out what exactly went on. And you know, I'll admit to you, like 8 times out of 10. Things that seem really good the previous day will turn out to be a dud when you later find out more about it. But I think I just talked about this at lunchtime. If it really is a dud, my suggestion is to give up on that and go pursue more fruitful avenues, because you know it takes.
Write it up. Write it up.
Oh right, let's go like
That's true.
Yeah, I hear what you're saying, but I think that is another place where a sort of pre-protocol is important.
Oh yeah, the pre-reg, yeah.
Repeating the same, oh, that seems like a good idea, but actually not realising somebody's had a look at it as an instrument. And
Okay, I'll write up. There's a lot of duff instrument. There's a lot of oh yeah, the other thing about natural experiments, I guess, is like, because there's no big statistical model behind it, all of your friends in a statistical model, the covariates and a large amount of rich data you have, they're used as robustness tests. Throw them on the left side hand of the equation. If there's any sort of, if your treatment is confounded those, your natural experiment is not a natural experiment. But also, yeah, it's a terrifying robustness test, but because you specify in advance, should make for really good science and replication. Because and what I'm suggesting is also, it's commonly done in natural science, is to basically have these big punts and big conjectures, specify them beforehand, and see if the data fits. And you know, it's trial by fire over there, but they have lots of stuff that are replicatable, and social sciences is desperately in need of stuff that's replicatable.
I'm sorry, but we're getting kicked out of the room as kind of teaching after this, but we will be, well, I think it was putting you in where there's like a space, they call it the quiet space or working space around the corner. And then if you guys want to speak to mainly afterwards, or email, obviously. And thank you again very much.
Yeah, thanks so much for coming in, Meng Le. Sorry for being with COVID.
Thank you.
Yeah, if anybody wants to get in touch with him, get in touch with him. He's really great to work with. We work together at the moment, and I would love to work with him more.
Okay.
Thank you.
Thank you very much.